This assessment asks us to predict the product of an aldehyde reacting with ammonium chloride. Now, we can look at ammonium chloride and think of it as an acid, even though it's not a very strong acid, in the presence of the carbonyl. Now, as nucleophiles, amines don't need the protonated carbonyl present, but it does make the reaction slightly faster. And so we can imagine this reaction starting out by the protonation of the carbonyl with ammonium. Now, based on pKa's, this is not going to be a very favorable reaction. In fact, we can write it like this just to emphasize that. But even if we form a little bit of that protonated aldehyde, we can now use this more electrophilic species to be attacked by ammonia. When that happens, the nitrogen is going to bring along its proton, at which point we could use some other base in solution. Maybe there's more ammonia, maybe we can use water. Again, not going to be a particularly favorable deprotonation. Let's use ammonia just so we feel a little bit better about the deprotonation. But when that happens, we're going to end up with this product here. Now, in this step, we would have made ammonium, so we still have more ammonium around. We could use a molecule of ammonium to do the protonation of the hydroxyl group. The idea being that we need to turn that into a better leaving group. If we do that reaction, we now have the following. Which is a good leaving group. Water is present, now is a good leaving group. We wouldn't expect this acid-base reaction to be particularly favorable either, but even if a little bit of this forms, it can react further by having water leave. Now, when we draw the product of this step, we're going to start to see why all of this makes sense. Because if we get to here, and we draw the carbocation here, what we notice is that this carbocation is right next to a nitrogen, which has a lone pair and is a good electron donating group. As a good electron donating group, we can draw a resonance structure. I'm going to erase that. This should be a resonance structure. We're going to show that this cation is resonance stabilized to give this intermediate here. What would happen next? Well, when we stabilize this cation by resonance, we see that we have what is essentially a protonated iminium ion, and now we can remove that proton, once again, either with water or something like ammonia. Let's use ammonia since it's a stronger base. And our product that we end up with is this imine. So the product of an aldehyde reacting with ammonium chloride is an imine. Recall that this is a reaction that can be done using acid to make the ketone or aldehyde a better electrophile, but it can also be done without. So if we had run this reaction with ammonia, we would get this as well. And the fact that it works with ammonium chloride and ammonia, while sometimes it makes it a little bit confusing mechanistically, it kind of reminds us why we can do these less favorable proton transfers.